Hey guys, welcome to Conceptual Geometry, Lesson 1.10, Pythagorean Theorem. Let's consider the right triangle below with sides 3, 4, and 5. And I'd like you to draw squares using each side as a side of the square. So let's see if I can do this here. If I pick the side of 3, I'm going to draw a square that has 4 sides of 3. I'm going to divide that up into blocks. So each side of the square is 3 blocks. So notice when I create that square, I have 9 blocks total. Okay, let's try that with the 4. I can see already it's not going to be perfect. I have to maybe go down here a little bit if I try and make it a true square. And each side here would have 4 blocks. So in this one, if you count up all the blocks, we have 16 total. 4 times 4. And then lastly, let's do this with a side of 5. So this one obviously is going to be the hardest one. I'm going to try and do the best I can here to make it somewhat accurate. A little bit hard to do freehand. Okay, so this is a square, 5 by 5 square, so it's got a total of 25. So now what I want you to do is I want you to notice these squares here. That's 9, that's 16, and that's 25. And I want to see if you can create a math equation with them. Well, if you focus on the numbers, we've got 9, we've got 16, we've got 25. Those are numbers we call perfect squares because 3 squared equals 9, 4 squared equals 16, and 5 squared equals 25. But notice the 9, the 16, and the 25. Well, one thing you could do is take 9 plus 16, and guess what? That equals 25. So there's a possible math equation. 9 plus 16 equals 25. Or, like we just mentioned, 3 squared, there's the 9, plus 4 squared, there's the 16, equals 5 squared. That's a very powerful relationship when it comes to right triangles. So given a right triangle, and I'm going to label the sides A, B, and C. From up above, we can say that A squared plus B squared equals C squared, and that's called the Pythagorean theorem. A squared plus B squared equals C squared. This is one of the most common theorems. Your parents probably still remember this from when they were in high school. Everybody remembers A squared plus B squared equals C squared. But what I want you to really remember, what does A represent? What does B represent? And what does C represent? So I want you to look at the bottom of the page first and notice here this word hypotenuse. Hypotenuse is what we call the longest side of a right triangle. And it's always across from the right angle. So in this triangle here, here's my right angle. I go across from it. This side C is the hypotenuse. That's the longest side in the right triangle. So instead of just remembering A squared plus B squared equals C squared, I prefer if you remember leg squared plus leg squared equals hypotenuse squared. That is your A squared plus B squared equals C squared. It's always leg squared plus leg squared equals hypotenuse squared. Okay, so my Pythagorean theorem, again, I want you to rewrite it. Leg squared plus leg squared equals hypotenuse squared. And from here on out, we're really going to use this A squared plus B squared equals C squared. But again, letters without any meaning doesn't really help you out in mathematics. So it's leg squared plus leg squared equals hypotenuse squared. So my first example, I want you to determine if each set of sides forms a right triangle? Well, it will only form a right triangle if this works. So what I'm going to do here is I'm going to set up that equation. 3 squared plus 4 squared equals 5 squared. Now what I want you to do on your calculator is you're going to plug this in. 3 squared plus 4 squared. I don't care what they are individually. You're just going to do 3 squared plus 4 squared. Well, we've already done it. That's 25. Then you do 5 squared. That's 25. So yeah, 25 equals 25. This answer is yes. Those sides do make a right triangle. How about 2, 3, 4? Let's do the same thing. 2 squared plus 3 squared equals 4 squared. Put these into your calculator. You get 13. Well, 4 squared is 16. No, that does not work. So if it does not work, the answer is no. 5, 12, 13. Okay, so we test it. 5 squared plus 12 squared equals 13 squared. Let's put 5 squared plus 12 squared into our calculator. We get 169. 13 squared is also 169. So yeah, that works. The answer is yes. So they're not all combinations work. All right, you have to test it. So next we have something that are called Pythagorean triples. And there's certain combinations that always make a right triangle. You probably noticed 2 of them up above. 3, 4, 5. And I'm going to write it underneath 5, 12, 13. Well, what's cool about these is that any multiple of those combinations work as well. So if I take this 3, 4, 5, and I take all those numbers and I multiply it by 2, I get 6, 8, 10. Well, that's also a Pythagorean triple. I could also take these numbers and multiply them by 3. So 3 times 3, 4 times 3, 5 times 3. That would give me 9, 12, 15. So these are just some combinations that you're going to see from time to time. And when you do see those, you can just say it's a Pythagorean triple. It'll save you a little bit of calculation time. All right, let's actually find some missing sides. So notice in all of these examples, we are given right triangles. So I'm going to be using the Pythagorean theorem. A squared plus b squared equals c squared. But what I need to remember is that this is the hypotenuse. The longest side always goes here. It's not just the x, the longest side. So my first example, I've got 5 squared plus 12 squared equals x squared. Well, since the x is by itself, I'm going to put all of this into the calculator. I don't care what 5 squared is. I don't care what 12 squared is. I want to know what this is. So put all of this into the calculator in one shot. Some of you guys probably recognize this from up above. We've already done it. That's 169 equals x squared. Well, now how do you get the x by itself? Here's an algebra step you might remember from last year, but to get rid of my squared, I need to take the square root of both sides. So we're going to have to practice that on the calculator when you get to class. But the square root of 169 is 13, and there's your missing side. Okay, part B. This one's a little bit different. What I always like to do is I like to identify the hypotenuse, because I know this is got to go by itself on that side of the Pythagorean theorem. So I'm going to start this one with my leg squared plus leg squared. So that's x squared plus 8 squared equals 17 squared. And the most efficient way to do this is to subtract 8 squared. I don't care what 17 squared is. I don't care what 8 squared is. I'm going to put this into the calculator all at once. That's what's nice about our graphing calculators or even scientific calculators. It allows us to do this. Saves us a lot of writing. So I'm going to put this into the calculator, and I get 225. And then we're going to take the square root of both sides, and the square root of 225 is 15. Okay, a couple more here on this page. Once again, I'm going to use Pythagorean theorem. Here are my legs. Leg squared plus leg squared equals hypotenuse squared. Okay, that's going to be x squared plus 3 squared equals 7 squared. I need to subtract this over. x squared equals, I'm going to put this into the calculator. That's not the same as 4 squared. You type in 7 squared minus 3 squared. If you did that correctly, you should get 40. Now you take the square root. Notice you're going to get a decimal. So when you're doing these, they're not all going to be integer answers, but if you get a decimal, look at the directions. It says to the nearest tenth if necessary. So I didn't need to round that one because it was just 13. That was just 15, but now I need to round to nearest tenth. So looking at the calculator to the nearest tenth, I end up getting 6.3. Remember, the tenth is 1 decimal place. Okay, and the last one on this page, leg squared plus leg squared. So my two legs are 8 and 14. So that's going to be 8 squared plus 14 squared equals x squared. Now notice, your x is all by itself. So I'm going to put this stuff here into the calculator. 8 squared plus 14 squared, I got 260 when I did that on the calculator. And now I take the square root. And the square root of 260 to the nearest tenth is 16.1. Okay, let's look at our last page of notes. 3 more examples here. First one is a multiple choice. It says the set of integers 3, 4, 5 is a Pythagorean triple. Another such set is. Unfortunately, there's no shortcut here. I have to set up the Pythagorean theorem for all of these and see if it works. Okay, so it's 6 squared plus 7 squared equals 8 squared. If I get the same number on both sides, then there's my answer. If you put this stuff into the calculator, you get 85. 8 squared is 64. No, it's not that one. Choice 2, 6 squared plus 8 squared equals 12 squared. Put that stuff into your calculator. I got 100. Some of you might know 12 squared is 144. If not, throw in the calculator. Not equal. No. Oh boy, next one. 6 squared plus 12 squared equals 13 squared. Put 6 squared plus 12 squared into the calculator. I got 180. 13 squared is 169. Of course not. Now you know that's going to be choice 4. Let's just show it. 8 squared plus 15 squared equals 17 squared. If you put this into the calculator, you get 289. And you put 17 squared into the calculator, you also get 289. So yes, it's this one right here. Choice 4. Of course, it's the last one. All right, example 4, a word problem. This is going to be a little bit challenging. All right, we're going to see lots of ladder problems because a ladder up against a building or a house or a wall makes a right triangle. So very quickly here, I'm just going to come up with a drawing to show you how it works. I have a wall. Sorry, it's a little messy. Let me make this neater. So I have a wall. I have the ground. Maybe some of you guys haven't been on a ladder before. And then my ladder leans up against the wall. So the ladder is always going to be the diagonal. It's going to be the hypotenuse. Okay, so let's talk about this specific one. It says a woman has a ladder that is 13 feet long. So this diagram over here is going to represent my ladder's 13. If she sets the base of the ladder, so the base is the bottom, on level ground, 5 feet from the side of the house. So if here's my wall, on the ground 5 feet away, that means this side right here is 5. How many feet above the ground will the top of the ladder be? So the top of the ladder is up here. How many feet above? You're looking for this side here. That's going to be my x. Okay, so that's your right angle. We're going to set Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. X squared plus 5 squared equals 13 squared. Now, when the number is on the same side with the x, I'm going to subtract that over. Minus 5 squared minus 5 squared. X squared equals, that gives me 144. Now I square root, and x is 12. So there's my choice, choice 4. And one more, last one. It says, how many feet from the base of a house must a 39-foot ladder be placed so that the top of the ladder will reach a point on the house 36 feet from the ground? So that sounds very complicated. Remember, ladder questions, we draw a right triangle. Okay. It says a 39-foot ladder. So the ladder's 39 feet tall. There's your ladder leaning up against the house. That's 39. The top of the ladder will reach a point on the house 36 feet from the ground. So on the house, 36 feet from the house, or from the ground, sorry. This is the house. So on the house, 36 feet away. That's going to be this side. How many feet from the wall? Okay, so now it's going to be Pythagorean theorem. That's no surprise. We just need to get the numbers and the variable in the right spot. So here are my two legs. It's going to be x squared plus 36 squared equals 39 squared. So these numbers are a little bit bigger. Good thing we have a calculator. I'm going to subtract 36 squared. That gives me x squared equals, I got to throw that into the calculator, 225. Then I'm going to take the square root, and I get 15. So it's going to be 15 feet. All right, great job, everybody. That concludes day 10. Actually, that concludes unit 1. So we're going to get some review going, and we're going to be testing here in a few days. As usual, guys, reach out if you have any questions, and thanks for following.